Hello everyone, this is Zukhruf from InfoSharing 360. In today's lecture, we'll explore a new topic that I've prepared by carefully going through handouts, presentations, university video lectures, and my own research. Let's take a look at what we'll be covering. So let's get started. Ever wonder how factories plan to make complex products? They often use MRP. MRP stands for Material Requirements Planning. It's a computer system that helps factories plan production. Here's how it works. MRP takes the master schedule. That's the detailed plan saying what finished products to make and when, and breaks it down. It figures out three key things. First, what parts or materials are needed. Second, how many of each are needed. Third, exactly when they are needed. MRP is especially useful for manufacturing complex products with many parts. Think about making bicycles. If a factory plans to make 100 bicycles by May, MRP calculates everything backwards. It knows it needs 200 wheels, that's 2 per bike, by April 15th. It needs 100 frames by April 10th, and it needs 500 screws by April 5th. In short, MRP ensures the right materials arrive at the right time to keep production running smoothly. Next, we have material requirements planning, which requires three essential inputs to function. First, master schedule, the production plan specifying what finished products to manufacture and their completion dates. Second, bill of materials, a comprehensive list of all components, parts, and materials required to assemble each finished product. Third, inventory records, real time tracking of all materials and components currently available in stock. Moreover, MRP systems may use two supporting inputs. Product structure trees visually map component relationships, while cumulative lead time calculates total production duration. These five inputs enable MRP to generate accurate material plans. Next, the MRP processing steps exist to calculate exactly what materials to order, when to order them, and how much to get, ensuring production never runs short or wastes money on excess stock. Here's how each step contributes. First, gross requirements means calculating the total parts needed before checking current stock. Second, scheduled receipts refers to parts already ordered that will arrive soon. Third, projected on hand is estimating future inventory after using stock and receiving shipments. Fourth, net requirements identifies the actual shortage after subtracting available stock. Fifth, lot sizing. Decision involves choosing order quantities using methods like lot for lot, order exactly the missing amount. Fixed period, order enough to cover a set time frame. Economic order, quantity, calculate the most cost-effective batch size. Part period, match order size to target holding costs. Sixth, planned order receipts determines when materials must arrive. Seventh, planned order releases calculates when to place orders accounting for delivery times. Notice how each step builds on the last, from knowing what's needed to when to order. MRP systems use two different methods to update their plans. First, a regenerative system. This method completely rebuilds the entire material plan at fixed intervals. It recalculates every requirement from scratch during each run. Second, net change system. This method updates only affected items when changes occur. It continuously adjusts requirements in real time for modified parts. MRP generates two types of outputs, primary and secondary. In primary outputs, first, planned order releases, what to order and when to place orders. Second, planned order receipts, when orders will arrive. Third, changes to existing orders, adjustments to current orders when needs change. Fourth, inventory status reports, updated stock level information. In secondary outputs, first, performance control reports tracks how well production plans are working. Second, planning reports helps with long-term forecasting. Third, exception reports flags urgent issues needing attention. These outputs guide both immediate actions and strategic decisions. The part period model helps find the best order size. It balances two costs. One, setup cost, that is the cost to start making or buying items. Two, holding cost, that is the cost to store extra inventory. A part period measures extra stock over time. Example, if you keep 20 extra parts for 3 time periods, that is 20 times 3 equaling 60 part periods. The target is the economic part period or EPP. EPP balances setup cost and holding cost. Calculate EPP like this: setup cost divided by holding cost per unit per period. In our example, 8,000 divided by 100 equals 80 part periods. I explained this step by step above for you. I won't be explaining the complete example as I have made it simple for you all. In the last topic of this lecture, MRP delivers four key advantages for manufacturing. First, low in-process inventory levels reduces work in progress stock and associated storage costs. Second, material requirement tracking clearly shows what parts are needed and when they're required. Third, capacity requirement evaluation assesses whether production resources can meet demand. Fourth, production time allocation enables efficient scheduling of manufacturing time. Together, these optimize production flow while reducing waste. Please don't forget to subscribe our YouTube channel InfoSharing 360. Thank you for watching this video.